Waves is all about trying to build a highly accurate, localized accessibility forecast to help operational teams improve their management of offshore accessibility. RWE have partnered with us, and we've built the solution around a kind of live operational scenario. So just a little bit of background on Cognitive. The company was formed in 2018, 3 founders who'd previously worked within E.ON and then more latterly Uniper. And for probably a decade previous, they'd been the people instrumental in E.ON and Uniper's asset health monitoring and maintenance optimization solutions. So a very deep background in data science and machine learning applied to real world problems in the energy sector. What that's meant for Cognitive since we were founded is that we've been able to be an extremely innovative and hopefully quite dynamic organization. And some of the things we're proud of delivering in our short history is building out architecture for cloud-based data historians. So we're able to have an infinitely scalable operational data cloud historian that's instantly accessible across the web. We've got a really interesting and highly usable advanced pattern recognition solution for operational teams to do root cause analysis. And we've applied AI for wind performance analysis and are seeing some really excellent results in that tool. But Waves is what we're here to speak about, and that's part of our maintenance optimization offering. But it's a really interesting and sort of exciting opportunity to use machine learning techniques in a very varied and kind of imprecise environment. So what is the challenge? You have a highly complex interaction of many metocean weather variables, along with asset design decisions, vessel capabilities, crew competence, all playing into a daily decision of whether it's safe to work offshore. Overlaid on that is the challenge of how we make that decision, because forecasting is so challenging with the multivariate problem. We ask numerous people through the day to contribute to the decision. So it might be a marine coordinator in the control room in the morning, followed by a vessel skipper, followed by a series of technicians, all asked to make some sort of dynamic assessment of whether or not it's safe to transfer offshore. This inevitably results in inconsistency of decision making, and it doesn't take much delving into offshore stats to see crew transfer vessels consistently as the highest cause of incidents in offshore wind from the G+. And everybody who is involved in operating offshore wind will know the frustration on inefficiencies of having mobilized resources that you can't deploy because of poor weather conditions. So our kind of working thesis was that with data tools available to us in the modern age, there should be a way to apply some of these techniques to make a better decision around this vital aspect of offshore operations. How we went about it, I guess, for anyone involved in machine learning and big data applications, I guess the clue is in the name with big data that you need a large data set in order to apply these techniques. Fortunately, what weather forecasters seem to be excellent at is creating a large amount of data. So for some of the data feeds into this model, we've been handling, or let's say extracting from 3 petabytes worth of data, which is a number I don't even compute, but it sounds like a big number to me. We've based the model for RWE on WaveWatch 3 and Meteo France wave models, which give us a 6-day look ahead. And the model is basically built using 17 metocean variables combined into a machine learning model, and then categorized with the operational history from wind farms. So your go, no-go decision then informs the model to learn which conditions, which combination of conditions it can allow or recommend access. We've demonstrated that technology could work and be a big step forward for the operational decision making, which then has led RWE to purchase the tool in a live deployment. So the next slide here shows you the live app was built for RWE. The advantage of this approach to a machine learning solution is that it puts the ownership of training the model in the hands of the site team, and it really helps with buy-in as to its outputs and understanding why it's making the decision that it is. So finally then, with new customers, we go through a build phase where we can incorporate data into our architecture. We can put in local weather forecasts if sites have particular forecasters that they find reliable. We can build in live data streams, build a model, and test and validate it against historic operational logs. We then deploy that with our customers either through our front end, or it's very easily integrated into customer existing applications, and go through this period that we're in with RWE now of refining and improving the model feedback, all with the goal that an application like this only works if you culturally embed it within an operational team. There's no point in having a fantastic solution that just sits there unused in the background. The key to any such implementation is that people trust what the model's saying, they understand it, they have access to it, and I think crucially for us is that site teams feel ownership of training this to give them the access threshold that is right for their site.